In this next section, we're going to be writing equations. So each of the problems give you a little bit different information. You have to write an equation for all of them. So write an equation in slope-intercept form with a slope of -5/2, that's an m, and a y-intercept of 3, that's a b. So this is the easiest one out of all of them. I'm already given the m and the b, and we have slope-intercept form where all I'm going to do is plug in the -5/2 x, 5/2 for the m, x plus b, but instead of b I plug in 3. That is as easy as that one gets. Okay, so that one was supposed to be a give me problem. The next are going to be a little bit more difficult. The next one says write a linear equation in slope-intercept form passing through these points. So because I am not just given the m and the b, I have more information to get. I have a two-step process here. The first thing I'm going to do is try to find the slope. Now once I get the slope, then I'm going to, step 2, use that slope and one of the points, we'll say just one of the points, we are given 2, but I only need 1, to get an equation. So that's my game plan, okay? So in order to find the slope, in this case, I have 2 points. So I'm going to label them x1, y1, x2, y2. And I'm going to use the slope formula, which is y2 minus y1 over x2 minus x1. So y2 is -5 minus, because there's a minus in the formula, y1, which happens to be +1, over x2, which is -2, minus, because there's a minus in the formula, -4. So the minus comes from the formula, the negative comes from there was a negative on the 4. And this time I have to subtract my tops. So in the top, both of the signs are both negative, so that means I add my values and keep their sign, so that's -6. In the bottom, minus a negative. Whenever you have two negatives right next to each other, you can add a line and change the sign, so that becomes -2 plus 4, which is +2. And then that reduces, -6 over 2 is -3. So I'm going to take that m equals -3 from my first step, and I'm going to use one of the points. At this point, you can pick which point you like better. I'm going to go ahead with 4, 1. If you wanted to use -2, -5, that's fine. You're just going to have a little bit different work, but your answer is going to be the same as mine. So now I have a point and a slope, which tells me I need to use point-slope form. So I'm going to go ahead and write the formula out. If you get in the habit of writing the formula out every time, then you start memorizing it. Y minus y1. Well, who is my y1? That's 1 from the green, okay? Equals m. Who is the m? Well, that's the -3 that we got in step 1. Parentheses x minus, because there's a minus in the formula, x1. Now x1 happens to be -4 in green. Okay, so I hope you understand where all of those values came from. And now I'm going to distribute. So actually, before I do that, minus a negative, that's really add a line, change the sign, that's like +4. So I have y minus 1 equals, distribute here, -3 times x, that's -3x. -3 times +4 is -12. And the last step, I can add 1 to both sides. So my final answer is y equals -3x minus 11, because -12 plus 1, they're different signs. You subtract and keep the larger values sign. Excellent. Let's do this again. The next problem is similar to 27, but we have different information. So my steps are going to be the same. Just like on number 27, I'm first going to find the slope. And then step 2, I'm going to use that slope that I just found in step 1 and the point to get an equation. But again, finding slope is different than I did on number 27, which is why I made you practice both. So this problem says write a linear equation in slope-intercept form passing through this point and parallel to this line. Parallel to that line. So I need to, I have a point, but I don't have a slope, so I need to work on slope first. So the only piece of information they give me is this equation here, and I want a parallel slope. So I need to solve for y. So you can pick the 2 up and move it to the other side. using transposition. When you pick it up and move it, it changes signs. Everybody else stays the same. Or if you don't like that, you can always subtract 2x from both sides, and that also gets you the same answer in the same amount of steps. Now I'm going to divide all terms by the coefficient of y, which gets me, let's see, y is equal to negative 2 over negative 4. That reduces to positive 1/2 x minus 5/4. So the slope of this particular line is 1/2. But I care about the parallel slope. So what is parallel to a slope of 1/2? Well, 1/2, because parallel slopes are equal. That's why that is true. So once I have the slope, I'm going to take it to step 2, so that's 1/2. And I have a point, and that's going to be 4, negative 3. And then I'm going to use, now that I have a slope and a point, I'm going to use point-slope form. I love that they named it that way because it's very clear about what you need in order to use a form, a point and a slope. So we have y minus y1. And it might be in your best interest to label these x1, y1. So my y1 is negative 3 equals m. The m that I have is 1/2 from the first step, parentheses x minus x1, which in this case is that green 4. Okay, so this is the equation, but it's not in slope-intercept form, so I have to distribute, combine like terms, make it pretty. So now I'm going to add a line, change the sign. That makes that y plus 3 equals 1/2 times x. That's easy. That's just 1/2 x. And 1/2 of 4, that's also easy. Half of 4 is just 2. Last step, I'm going to subtract 3 from both sides. And that gets me y is equal to 1/2 x minus 5. And that's the answer. This next one is similar to the previous two, except the first step, finding the slope, again is a little bit different than the previous ones. But my first step is going to be find the slope. My second step is going to be use that slope that we just found in step 1 and the point that was given to get the equation. So step 2 is basically the same on all 3 of those problems. It's just the way you have to find the slope is different. So the information that was given, it has to pass through the point 5, 3 and perpendicular to the line y equals negative 4x plus 2. So perpendicular. So this is a little different than the previous one. But the one nice thing is it's already in the form that you want. So the slope of this line is negative 4. It's right there, mx plus b. So the m is negative 4. So what is perpendicular to it? Well, perpendicular is called opposite and reciprocal, perpendicular slopes. So negative turns to positive, and 4 over 1 turns into 1 over 4. So my slope is 1/4. Just as a reminder, perpendicular, this symbol is perpendicular, by the way, that symbol. So perpendicular slopes are opposite reciprocal. So top to bottom, bottom to top, and opposite means positive to negative, negative to positive. Okay? So now I've got my slope. I already have the point that was given to me. I'm going to go ahead and label that x1, y1. And if you have a point and a slope, you use point slope form. So you have y minus y1. In this case, my y1 happens to be 3. The m is 1/4. Parentheses x minus x1, which happens to be 5. Alright, so now I can, this is the equation of the line that we were looking for, but because it's not in slope-intercept form, I need to distribute, combine like terms a little bit. So when I distribute, 1/4 times x is easy, that's 1/4 x. 1/4 times 5, sometimes students have a hard time with that, so if you remind yourself that 5 is a numerator and it goes in the top, that'll be helpful. So 1 times -5, that's -5 on top. 4 times 1 is 4. And then I'm going to add 3 to both sides. So the multiplying of the fractions wasn't actually all that hard. But when you have to now add them, it gets a little bit more tricky. So I'm going to come off to the side here and add 5/4 plus 3. And I'm going to put that 3 over 1. So the LCD between 1 and 4 is 4. So the first fraction stays the same, but the second fraction I need to change. The denominator is 1 and I need it to be a 4, so I'm going to multiply both the top and the bottom by 4, which gets me 12/4. Now don't reduce this. If you reduce it, you get right back what you had before. So at this point, now that the denominators are the same, we're going to keep them the same and add the numerators, which just gets you 7/4, positive 7/4. And that is my answer for that problem. Now these last 4, notice I didn't give you very much room to write your answers here. It's because there's not really all that much work to do. These are both parallel and perpendicular problems again, like the last 2 that we just did, but each one of these is a special case. X equals 1, x equals 2, y equals 3, y equals 4. All of those are either a Hoy or a Vux problem. And so because all of these are special cases, I didn't give you much room because it doesn't need much room here. So I'm going to go ahead and put Hoy Vux at the top of the paper just to remind you about which one is which. So let's see. The first problem has x equals 1. What kind of line is x equals 1? Is it a vertical line or a horizontal line? Vux. Okay, so it's x, so it's Vux. So I have a vertical line. And I want something perpendicular to a vertical. What's perpendicular to a vertical? Well, a horizontal line is perpendicular. So my first line was vertical, but I want a perpendicular one, which means I want a horizontal. So the vertical was x, perpendicular should be y equals a number. So my answer is going to be y equals, and then all you have to do is look to the point. Either you're going to pick 5 for the x or 6 for the y. So because this is y equals, my answer is just y equals 6. And it's that simple. Let's do another one. The next problem has x equals 2. I want parallel to x equals 2. Well, because it's an x equals, that's a vertical line. What's parallel to a vertical line? Well, another vertical line, which is another x equals. So my answer is going to be x equals some number. Which number could it possibly be? Well, you can either pick from 7 or 8, but because it's an x, it's the 7. One more time. Y equals 3. What kind of line is y equals? Well, y equals is a horizontal line. Okay, what's perpendicular to a horizontal? Well, perpendicular to horizontal is a vertical. And a vertical is going to be a Vux, x equals answer. So my answer is going to be x equals some number. Well, which number is it? Well, it's got to be 9. Because that's my x value of the point that it crosses through. And then our last problem here, we have y equals 4. What kind of line is y equals? It's a horizontal. And I want parallel to it. So parallel to a horizontal is another horizontal. So what letter am I going to choose? Y. So that gets me y equals some number. What number am I going to pick? Well, it's between 12 and 11 and 12, but because it's a y value, it's the 12. So that is as simple as it gets there. And that concludes our review for the practice exam 1. Good luck on the test.